This video will demonstrate the difference between the soil type that actually exists at depth for the majority of the anchors versus the soil type described to exist by the district and therefore reasonably expected to exist by McMahon. The first segment shows drilling at tieback number 17 and demonstrates the soft goo that was encountered below 40 feet along the tieback axis as opposed to the hard soil/rock layer that was represented to exist by the district. Tieback number 17 failed its performance test in an ultimate unit friction value of some 1,300 pounds per square foot as opposed to the 3,000 pounds per square foot specified as being applicable in the soil below 40 feet along the tieback axis.
Here on Saturday the 7th, 65 feet, and that casing is in 48 feet, and we were able to push that casing in with no soil coming up the casing, which means that the end of the casing plugged with soil, and instead of advancing the soil into the casing displaced the soil into the voids and fissures that have to be existing in this quote-unquote hard soil rock layer material that we're supposed to be into.
This still image demonstrates that as the casing was installed at tieback 17, the soft, gooey soil was displaced away from the casing tip, consolidating the surrounding soil and demonstrating the loose, fractious nature of the underlying soil mass. Had the casing encountered the hard soil rock layer, as depicted in the contract documents, this would not have occurred. This segment shows the soft, gooey material being extracted below 65 feet along the tieback axis. As seen in the video, a handful of this material, thrown against the sheet pile wall, simply sticks to the sheets with no rebound whatsoever. Had I taken a handful of hard soil rock and thrown it against the face of sheet piles, it would have rebounded it off the sheet piles and fell to the ground.
This isn't hard rock soil layer. The tieback will just squeeze right out of that thing.
Yeah, once they get disturbed, it's coming out.
That's 75 feet.
What, 75 feet?
This is the stuff at 75 feet. There you have it. Slop. No tieback's going to hold in this stuff.
Now, at tieback number 5, McMahon hit the expected hard soil/rock layer at 40 feet deep along the tieback axis, as shown to exist at this depth in the contract plans. At this point, McMahon attached a split-spoon soil sampler to the auger stems so as to sample the in situ soil at 40 to 41.5 feet of depth. The video demonstrates that if this material had been encountered on all the other tieback locations, McMahon's planned use of compressed air to drill the anchors was both reasonable and appropriate. Due to the loose, fractious nature of the majority of the underlying soil mass, the district ordered McMahon to cease the use of compressed air for the drilling effort, thereby directing the means and methods of construction. As can be seen in the image of the soil sample taken at 40 to 41.5 feet, the material encountered at the represented hard soil rock layer contact was just that, a hard soil rock layer. And this particular tieback passed its performance tests without the use of post-grouting, due to the fact that it was embedded into the hard soil rock layer that was represented to exist for all tiebacks.
What's the difference between right here and over there?
Big difference. Big difference.
There's a big difference.
So this is the stuff we should be into. Going to the west, it's not that way. Or going to the east, I'm sorry.
That's the hillside right there.
See, if we were in this stuff, we could have been using air, no problem.
No buckery, huh?
This is the in situ sample taken at tieback number 5 at 40 to 41.5 feet of depth along the tieback axis. And it is exactly what was represented to exist in the contract documents. It is exactly what was reasonably contemplated to exist by McMahon for all of the tiebacks, and it is exactly why McMahon wanted to use compressed air in the drilling effort. The small soil cuttings that were observed to come out of the casing during the last video segment would have simply been blown out as opposed to being augered out of the casing orifice at the face of the drilling effort. McMahon has proven that a differing site condition exists, and the district's continued insistence that there is no DSC is not supported by the evidence, and as stated in McMahon's 4/9/12 letter, the district's answer to RFI number 25 is counterintuitive if, as they claim, MCI is in the, quote, formational material, unquote, that was expected to be encountered by MCI, i.e., the hard soil rock layer. If, for example, and obviously excluding tieback number 5, MCI is in the hard soil rock layer, as errantly implied by the district on the other anchors, then the given unit ultimate friction of 3,000 pounds per square foot was wholly overstated by the district based upon the empirical evidence of the performance tests on anchors number 10 and number 17, both of which failed their performance tests. If, on the other hand, the given unit ultimate friction of 3,000 pounds per square foot is applicable to the hard soil rock layer, as is obviously true for tieback number 5, then MCI's remaining tiebacks cannot be embedded into this hard soil rock layer, given the ultimate friction obtained with tiebacks number 10 and number 7, which were respectively 636 pounds per square foot and 1,353 pounds per square foot. The district cannot have it both ways. McMahon is entitled to an equitable adjustment in both quantum and time.